Assalamu alaikum. This is section 1, talking about naming chemical formula. Section 1, naming. Okay. So using chemical formula for chemical compound is really important because it gives a lot of information. For example, when I say Al2O3, how many information I can get from this formula? Number one, it shows the type of atom involved. So aluminum and oxide are involved in this formula. Number two, it shows the number of the atoms in each molecule. And here, the subscript 2 under the aluminum means it contains 2 atoms of aluminum and the 3 atoms of oxygen. It also can give me the ability to calculate the molar mass. If I know the mass number of aluminum multiplied by 2 and the mass number of oxygen 16 multiplied by 3, and I add them together, so I can get the molar mass of the formula. Also, there is an important point. When I say Al2O3, this formula can represent 1 molecule or it can represent 1 mole. Means I can say that 1 molecule of aluminum oxide contains 2 atoms of aluminum and the 3 atoms of oxygen. And I can also say that 1 mole of aluminum oxide contains 2 moles of aluminum and the 3 moles of oxygen. Also, the formula, the chemical formula, also gives me information about the valency of each element. So what comes first is always the positive, or in most cases, to be accurate, and what comes next is the negative. We put the valency of the second one under the first and the valency of the first under the second. So this automatically means that the 3 is the valency of aluminum, and aluminum comes first, so it is positive, and the valency is a 3. 2 here under the aluminum means, yes, it contains, the formula contains 2 atoms of aluminum, and it also means that the valency of oxygen here is 2, and it comes next, so it is negative 2. And since this is an ionic compound, so the charge also shows the oxidation number. So see how many information I get? I could calculate the molar mass. I knew that there are 2 aluminum atoms and the 3 oxygen atoms in the formula. I knew that the valency here of oxygen is negative 2 and the aluminum is positive 3, and I also knew the oxidation number. So this is why dealing with the formula and naming the formula is really important. Okay, how to name the formula? Naming system. So we will divide the chemical compounds into ionic and covalent or molecular. Molecular compounds are covalent compounds. The atoms are joined together by a covalent bond. Okay. Ionic compound consists of ions. What is ion? Charged atom, yes. Charged atom. Okay. This ion can be positive by losing electron or negative by losing electron. So the positive, we call it cation, and the negative, we call it anion. When any atom A lost electron, it converts to a positively charged ion, cation. When any atom gain electron, it converts to anion, negative charge. Naming ionic compound. If I have ionic compound, how do we name it? Ionic compound. So, first, we will divide them into binary. Ionic means consists of an ion and the cation, but it is monoatomic and monoatomic, or ionic compound with atomic ion. So if it is binary, how we name it? Okay, cation comes first. This is the system. Cation comes first. Okay? Then anion. Anion comes second. Cation is named as it is. We say sodium, we say potassium. And the anion, we put the root and then ide. Example. Sodium chloride, the most famous one. Okay, this is metal and non-metal. How we know the compound is ionic when it consists of metal and non-metal. So how we know that the atom is metal or non-metal? Okay, from group 1 to 13, this is important. Group 1 to 13 in the periodic table, you will have it in the exam. Metals. Okay? Group 1, the charge or the valency is positive 1. 1, 2, 13, because from 3 to 12, they are the transitional element. They are all metals, but they have different oxidation number or different valency. But group 1, they have a charge of positive 1. Group 2, they have a charge of positive 2. Group 13, they have a charge of positive 3. Group 14, they have a charge of positive 4 in covalent compound, but they make covalent compound, but even in covalent compound, they have a charge of positive 4. Group 15, they have a charge of negative 3, because 15, like phosphorus, it is 15, 2, 8, 5. So it needs to take 3 electrons. So it will make a charge of negative 3. Group 16, 2, 8, 6. So they need 2 electrons. They make a charge of negative 2. And the group 17, 2, 8, 7, for example, so they have a charge of negative 2. They need to gain. So if you memorize this, it will help a lot. So sodium is group 1. So this is metal. Teacher said from 1 to 13 they are metal, and the chlorine from group 17 you will see in the periodic table, so it is non-metal. So this is ionic compound. Sodium ion is monoatomic ion. Chlorine is monoatomic ion. So sodium comes first, and we call it as it is sodium. Chlorine comes second, and we say the root chloride, and then we add ide. Okay? More examples. lead PB lead مثلا sulfide. So lead is metal, it has a charge of positive 2. So please zinc and lead, memorize them. Lead and zinc are both positive 2. Sulfur group 16, it is negative 2. Okay, we put the valency of sulfur under the lead. We put the valency of lead under the sulfur. 2 and 2 we can simplify to 1 and 1. Okay, so it will be PPS. How we name it? The cation is named as it is. Sulfur we put the root, sulf, and then ide. And pay attention, because this is very important what I did here. When I say aluminum Al2 oxide O3, if you change the subscript, you change the formula. I cannot make it AlO3. This is something else. So any molecule of aluminum oxide, it consists of 2 aluminum and 3 oxygen. Never change the formula. If you make it AlO3 or Al3O4, you are talking about different formula. طب here teacher, PP2S2, when we make it PPS, we changed the subscript. Did we change the formula? No, because you didn't change the ratio. Because when I say here pp2s2 means each atom of lead react with with an atom of sulfur, and here also pps, each atom of lead react with atom of sulfur. So changing or simplifying the subscript here, if it has a lowest common factor, this is not changing the formula. But if you have Al2O3 and you make it AlO3, you are talking about different formula. You cannot do this. Okay, when we take, let us say, calcium nitride, calcium and nitrogen. Calcium group 2 have a charge of positive 2, they are cation, so it comes first. Nitrogen non-metal, so this is an ionic compound. Calcium comes first, and we call it as it is calcium. Nitrogen comes second. It is positive, it is group 2, so it is positive 2. This is the oxidation number, and the charge also. Positive 2, and so we put this under the nitrogen, okay? Nitrogen group 15, it is 7, so it is configured to 5. It has 5 electrons in the outermost. It needs 3 electrons, so it has a charge of negative, what is this? Negative 3, okay? So the 3 is put under the calcium, so it will be Ca3O2. Okay, type. Count the total. Yes, N. Okay. Type. So Ca3N2. Name it, so calcium, cation comes first and it is read as it is, or it is named as it is, and then nitrogen, we put the root and then ide, so it will be calcium nitride. Type. The charge of the calcium is positive 2, the number we put under the nitrogen. This is its oxidation number, by the way. In ionic compound, the oxidation number of each ion is the charge on this ion. And the nitrogen has a charge of negative 3. This is its oxidation number. If you multiply negative 3 times 2, so you have a net negative charge of negative 6. If you multiply positive 2 times 3, so you have a net positive charge of positive 6. Negative 6 and the positive 6 is the total, the algebraic sum of the total charge, or the total oxidation number is 0, and the compound is neutral. So this is the way we name the ionic compound. Sometimes he asks you to name it using a stock system. So what is the stock system? Stock system. Sometimes the cation has more than one valency, has more than one oxidation number. So in the stock system, you mention this. You point at the valency of the cation in the compound. Example, copper. Copper can be monovalent in some compound and divalent in other compound. So with oxygen, it can make a formula of CuO, and it can make a formula of Cu2O. What does this mean? This means that here, the normal oxidation number for the oxygen, I'm sorry for this, a crazy pen, negative 2, so we put it here. We put it here, okay, and but CuO, we don't see something, means it's 1 and 1. This means that there must be here 2, and this means that the copper here is positive 2, right? And I said if you have something you can simplify, so we can simplify this as CuO. So the copper here is divalent. While here, this is the normal oxidation number for oxygen. Oxygen is 826, it needs 2 electrons, so it is divalent anion. So this is why we put the 2 under the copper, and here we have nothing. That this means that we have here 1. And this means that the valency of the copper is positive 1. So see, the copper can be positive 2 and it can be positive 1. The Stokes system shows the valency of the cation in the compound. Yani, if I say name it, so you will be in the prefix system the normal one without the Stokes system or something. Type. The copper comes first, the cation comes first, and we name it as it is copper oxide. The anion comes first, and we put the rule and then ide. So if I ask you to name it without a Stokes system, the normal naming, so it is copper oxide. But when I ask you name it using the Stokes system, means you have to mention the valency of the cation. And we mention it by putting it with a numeral Roman number. So here the copper is positive 2, so we write it like this. Copper 2, see, oxide. This is the Stokes system. Copper oxide without a Stokes system, normal naming, copper 2 oxide using the Stokes system. You mentioned the valency of the copper here. Here, copper oxide normal, Stokes system, it will be copper 1 oxide. Okay, another example. When I say that, what else? You help me? Iron, yes, iron can have a charge of positive 2 or positive 3. So I can say iron oxide and iron oxide also. See? Here the subscript is different. These are 2 different compounds. These are 2 different formulas, although they consist of same 2 elements. Type. I know that the normal oxidation number of oxygen is -2. And this means here under copper must be 2. Here I have nothing, means it was 2 and we simplify it, see? Okay, FeO. So here the copper must be positive 2, divalent. Here this 3 under the oxygen, so must be the copper positive 3 because cation comes first, so the first element positive and the second is negative. Okay? And we cannot simplify. So this is iron oxide. If I ask you to name it without a Stokes system, it is iron oxide in both cases. Using the Stokes system, so it will be iron here 2 oxide and here iron iron 3 oxide. Fine? Okay. Fine. What if the ion is polyatomic? Polyatomic, we are still in the ionic compound. Ion. This is an ion, but consists of more than 1 atom. But we deal with it as 1 unit with a netted charge. It can be positive, and you have only 1 example here, ammonium NH4. Okay, the charge is positive 1. It is this positive 1, is not on the hydrogen alone, is not on the nitrogen alone, it is on the whole ammonium ion. And it can be negative. The negative can be monovalent, means a charge of -1, like hydroxyl. This is called hydroxide. You have to memorize it. Like chlorate, -1. like nitrate NO3 -1. Okay, like nitrite NO2 -1. Okay, it can be divalent, يعني -2 divalent anion, like chromate CrO4 -2 all together, sulfate SO4 -2, carbonate CO3 -2, or it can be trivalent, and you have only one example here, which is phosphate BO4 -3. How we name it? As they are. This is ammonium, this is hydroxide, chlorate, nitrate, nitrite, chromate, sulfate, carbonate, phosphate, and you put it in the compound and you name it as it is. And we will take some examples. Calcium sulfate, put the formula of calcium sulfate. Okay, I know calcium group 2, so it is +2. Sulfate polyatomic ion, divalent anion. Cation comes first, and then anion SO4. This is +2, this is -2. We put the valency here and the valency here. 2 and 2 goes together, so it will be 1 and 1. So this is the formula, calcium sulfate. Okay? Ammonium phosphate, ammonium, this is positive, so it comes first, ammonium, sulfate, sorry, I said phosphate, okay, right. I memorize that ammonium is +1 and phosphate is -3. The positive comes first, ammonium, NH4, and the phosphate comes second, BO4. This is -3. We put it under the ammonium, and this is +1. We put the number under the phosphate. One you may not write it, so it will be NH4 all 3 PO4, ammonium nitrate. Okay. Right. Name this compound. Calcium. This compound. You name it. Okay. So this is the cation. So we name it as it is calcium. And this is the anion phosphate. This is a polyatomic ion, so we name it as it is. It is phosphate, okay? And notice that the calcium is divalent. We put the 2 under phosphate, and the phosphate is a trivalent anion, and we put the 3 under the calcium. If you multiply +2 times 3, it is +6, -3 times 2, it is -6, and the compound is ionic. The compound is all neutral. If I ask you to put the oxidation number for each species or for each element, so it is, okay, calcium is +2. Oxygen, the normal oxidation number of the oxygen is -2. -2 times 4 is -8. Okay, so the phosphorus must be +5, such that +5 and the -8 altogether is -3 if you want the oxidation number also. Okay, for molecular compound, we will deal it like this. Let us put one of them, P4 O10, for example. So we use the first prefix, tetra. And then the first one, phosphorus. We name it as it is. The second prefix, decaoxide, decoxide. And the second, we put the root and ide. So it will be tetra, phosphorus as it is. Okay. Okay, decaoxide, so it will come two vowels beside each other. So we'll remove the A and it will be oxide. Okay. CO2. How do we know that this is covalent? Because both are non-metal. Okay, so under carbon is 1, so monocarbon dioxide. If the one comes first, you cannot say it, so we say carbon dioxide. Okay, if I say H2O, H2O, so the water is dihydrogen monoxide. If the one comes first, you cannot to say it, but it comes after this, and the second element you will say it. So it's dihydrogen monoxide. Okay. طيب Si silicon O2 طيب monosilicon dioxide, and the mono comes first, so we can not say it, so it is silicon dioxide. This is group 14 and this is group 16. Both are non-metals, so we will apply the naming system of the non-metals, the subscript of the first, and then the first, the subscript of the second, and then the root of second plus ide. Okay? SO3. Okay? طيب, so خلاص, don't say monosulfur, we can say sulfur trioxide. If we will talk about oxidation number also, by the way, so this is -2, normal oxidation number. -2 plus 3, it will be -6, so this must be +6. Okay? طيب SO2, sulfur dioxide, the normal oxidation number of oxygen is -2, multiply to equal -4, so this must be +4. See, sulfur here has different oxidation number. Okay, here, and pay attention, when I say sulfur trioxide, is different from saying sulfate ion. If SO3 come with a charge, this is sulfate ion. If it comes without a charge, so it is sulfur trioxide. Okay, and see here that if oxygen alone is -2, -2 by 3, -6, so the sulfur here is +4. Such that +4 and the -6 altogether is -2. But here in sulfur trioxide, sulfur is +6. So this sulfate ion is different from sulfur trioxide. This is neutral, this is a compound, but this is a charged, this is an ion. طيب, in 2O5, dinitrogen pentaoxide. Yes, right. And so on. Naming the acids. Acid is the substance that dissolves in water to increase the hydrogen ion concentration. How we name it? Type. If it is binary acid like HCl, hydrogen chloride, +1 and -1. Okay? Type. HF, hydrogen fluoride. Oh my God. HI, hydrogen iodide. But what about oxy acids? Oxy acids. Okay, I think it's I. Oxy acid are the acids that contain hydrogen for sure, oxygen for sure because of the name, and a third element. Like what? HClO, HClO2, HClO3, HClO4. See, all of them contain hydrogen, oxygen, and a third non-metal, which is the chlorine. So how we name it? Okay, this is hypochlorous, hypochlorous. We need to memorize this. Hypochlorous. This is hypochloric. This is 4. Okay? طيب. So here, طيب, if chloric is contain 3 oxygen, so 4 means perchloric acid. Perchloric, يعني above 3 even, above the chloric. Okay? And this is hypochlorous. This is even less oxygen than the chlorous, so it will be, no. I'm sorry. This is chlorous. This is chlorous. Okay? This is chlorous. The pen is tired now. This is chlorous, and this contains oxygen even less than chlorous, so it will be hypochlorous. Hypochlorous. Okay? OUS? OUS. Okay. So hypochlorous, chlorous, and this is not. Not only the pen, which is tired, the teacher also is tired. Okay. Okay. Chloric and perchloric. Chloric and perchloric. So again, oxygen 1, 2, 3, 4. So it's hypochlorous, chlorous, chloric, perchloric. Okay? يعني let us make it like this. We memorize only chloric 3 and the chlorous 2. Less than 2, it is hypochlorous, less than 2. And 4 perchloric, يعني more than 3 oxygen. Perchloric, more than chloric. Okay? طيب, if you have H2SO4, dihydrogen sulfate, this is an oxy acid, so we call it sulfuric acid. Sulfuric acid. H2 CO3, so it is dihydrogen carbonate, yes, but as an acid because it contains hydrogen, oxygen, and another nonmetal, so it is an oxy acid, so we call it carbonic acid. Okay? Fine. Stock system. He can ask me a stock system for non-metal? Yes, he can. يعني stock system mainly for ionic compound, but for molecular compound he also can ask you. يعني for example, P2O5. Okay? This is non-metal because phosphorus group 15, oxygen group 16. The less electronegative atom comes first. We deal it as ionic. So which will be positive, which will be negative? The less electronegative atom comes first, which is phosphorus, and the more 15. And then to the right, electronegativity increases to the right. Oxygen comes to create 16, so it is more electronegative. So this takes a positive 3, and this takes negative 2, right? If you want to make the oxidation number. Diphosphorus pentaoxide. 2. Okay? Negative 10 and positive, no, here. Negative 2 times 10, negative 2 times 5, negative 10. So this must be positive 5, yes. Okay? So diphosphorus pentaoxide. The valency of the phosphorus comes under the oxygen. The valency of the oxygen comes under the phosphorus. This is the prefix system, diphosphorus pentaoxide. Type. Can he ask me to make it in a stock system? Yes, it is the same story. So this is phosphorus. Phosphorus phosphorus 2. This is the valence. Okay, oh my God. Here the valency of the phosphorus is positive 5. Okay, so oxide. Okay, when I say carbon dioxide in the stock system, so what is the valency of the carbon here? Carbon 4. Okay, this is the valency of the carbon. This is negative 2, and this is positive 4. So this is the valency of the carbon, carbon 4 oxide. This is so bad. Anyhow, we are done. So if you are asked to make the, the molecular compound using the stock system, you will make it the same way as ionic. The first element, deal it as cation and put its valency using a Roman number, and then put the second element as anion, put its rule, and then put it. Good luck.